we'll deep dive into Perceptron, the foundational building block that launched the neural network revolution. And it inspired by how a single brain neuron cell works. Welcome back to Extra Neuron. I am Sumit Kumar Das, and this is our next episode on Deep Learning Playlist. By the end of this video, you will understand what is a perceptron, how it works, why it is important, and how it gives the way for modern AI or what we saw today all about in computer vision or NLP. And also we'll see the limitation of it as well. And if you haven't watched the previous one in this playlist, do watch it. Link is attached in the description. So first is what is a perceptron? Perceptron you can think as a simple possible artificial neuron. Just like how our brain has billion of neurons that receive signals, process them, and decide what to give the or what to do the next. For example, let's take an example. If I am pinching my hand, okay, so this is an input, and this signal is giving some weight or some importance to this action at particular this point, because there is no other action in my body, but there is some action happening at this point, and it is sending some signal to my brain neuron. Let's take there is one of neuron is there. There are billion of neurons. Let's assume there is one neuron, and it is sending signal to that particular neuron. Okay, by pinching my cell, the cell in my brain will activate the neurons, which will produce the output as a pen. But in my other hand, where there is no pen, for this input there is no importance of this input because there is no activity happening here. So for this, my output from my brain neuron will give us no pen, but here it will give us the pen. A perceptron also works similarly. A perceptron takes multiple input, and every input has some weight associated with it, and this weight has some importance, and these weights combine with the inputs to give a aggregated result in the output as a yes or no question, which makes it as a binary decision, or we can say it as a binary classification. Okay, so here we have input x1. So this is our basically input. These w1, w2, and w3 are our weights. Okay, y hat is it is our output. Imagine you are trying to decide whether to play outside or not. Okay, to play outside there will be several factors involved in it. One can be how is the weather. Okay, it is sunny or rainy, means weather is good or not. You can rate it. So let's give an uh, what we can say, let's give an value of the weather as 1 to 10. Let me give its value as 1 to 10. Let's me write here 1 to 10 as weather, right? Then I will need time. I should have time with me to play, right? Let I have 1 hour with me. 1 hour, 2 hours, 3 hours, in hours. In hours. Then I need energy. I need energy. Whether I have energy or not. 0 or 1. Then there can be another factor. For example, clothes. Cloth, right? Do I have a uh, clean cloth or I don't have a clean cloth? Let me give us 0 or 1 again. So, among these four things, which one you can think as the most important input? Weather will be the most important input. Why? Because if it is rainy outside, I can't even play, even if I have time, energy, and good clothes with me. So let's give this weather some importance, or which what we call as wet point 4. It will be more important to us, right? Second important will be time for us. Even if the weather is good, I should have time to play. If I don't have time, what will do with the good weather? So let it give some importance as point 3. And similarly, I need some energy to play, right? So let it give us point 2. And cloth will be the least important. Even if I have a dirty cloth or a clean cloth, I can still play. I will prefer always clean cloth, but still that in dirty cloth also I can play. But it has some importance, but very less. So let's give the importance as 1, 0.1. So these all are weights, or which are here are W1, W2, and W3. So these are the weights only. I can mention the W1, this is W2, this is W3, and this is W4. So these are all our weights. This weather can be our x1, this time can be our x2, energy can be our x3, cloth can be our x4. So these are all our inputs, and these are I can say as weight. Weight means what is the importance of that input to deciding the output of that particular condition or particular factor. So here output is I can play outside. This is the output. Now with this input and weight, how to determine the output? I have the importance, I have the input. Let's say weather is 6, value of weather is 6. It can range from 1 to 10. 1 means very bad weather, 10 means very good weather. So for that we need a activation function. So this is our activation function. Activation function means it activates the input based on the importance of weight associated with it to give us the output. Basically, this is our uh, activation functions only, but I have expanded that to here just to have a better visual. Okay, so how we can decide the output? I told you the first example, right? I am pinching my hand. So here, in my both hand, in the left hand where I'm pinching, there are some weights. There are some activity happening, so it has some weight. Okay, but in my right hand, there are no weights because there is no activity happening on. So when this input with its importance of weight is going to my brain, then my brain will activate the cell, and cell will do some processing to give the output that yes, it is a pen. I am feeling some pain. So that cell, how it activate the input to give the output, that is activation function. Okay, so for that we need two things. One is z value, another is phi value. So z will be, just go down. So here z will be some, how we can calculate the z? It will be the combination of input and its weight combined, right? So it is an aggregation of input and weights. So how we can aggregate? W1 x1 plus W2 x2 plus W3 x3, if you have n number of inputs up to Wn xn. You have to aggregate the input. Now I aggregate the input, so there will be another term here, what is called as bias. So what is this bias? So bias is a small variability associated with the inputs or associated with the whole your logic or conditions. So for example, here the output is play outside or not. So there will be a bias that I am a lazy person or I am a active person. If so, this will consider this is not an input, but this is a bias. Okay, so if I am a lazy person, so whatever the weather is, whatever time amount I have, even if I am energetic, if I'm a lazy person, my internal tendency is let's not go to play. even if all inputs satisfied, my internal tendency will be let's skip the play. But even if I'm an active person, if even if weather is little bit bad, I have small amount of time, I am little bit tired, still I will try to go and play because I'm an active person. So this bias term will influence the output apart from the input. Even if inputs are having certain weights, the output will also getting affected by this bias. That's why we are combining this bias with the input aggregation as well. Okay, now we will calculate. So this phi of z, what we call as activation function, you have seen this activation function previously in logistic regression, right? Where we have by a sigmoid function 1 by 1 plus e to the minus z. This is sigmoid activation function, right? You have seen this in uh, logistic regression. In logistic regression, right? But here let's take an activation function as if it is 0 less than 0. If it is less than 0, output will be 0. If it is greater than equals to 0, output will be 1. It is a simple activation function. Okay. So now you have to calculate the output. How you can calculate? So you have to multiply your input value 6 multiplied by 0.4. Okay. So I can calculate here by z equals to, see, these are some random values, but in real neural networks you cannot decide value like this. So there are process how you can decide the weights value, how you can assign the values to the weights. Okay, 6 into 0.4 plus zero point 0.3 into 1, it's just a random calculation. Okay, zero point 0.2, let's say I don't have energy. Okay, let's say I have, I don't have clothes as well, I don't have clean clothes as well. Okay, but I am bit lazy. So this is the bias. I am bit lazy. 2.7 minus 2. So still it is greater than 0. So I can play. Even if I am lazy, weather is so good that and I have so much of time with me that I can go and play. It may happen if this value decreases, I will not go and play. Right? So this perceptron is also called as threshold logic unit. Okay. Why this is called as threshold logic unit? What we can call as threshold logic unit. Why? Because it is acting on some threshold. Okay, if it is less than 0, there can be other activation function, but there will be some threshold for any activation function will go be sigmoid, or we'll see in upcoming videos what are the other activation functions, like there are ReLU, there are tan h. So there will be some threshold, and there will be logic based on the threshold, it will assign some logic to unit. And why unit? Because it is a single value, it is a single perceptron. So threshold logic unit is also called as threshold logic unit. Okay, now, so now this is about single perceptron. Now we'll see a perceptron where we can have multiple output as well. In the same example, for the same weather, energy, time, and cloth factor, I can tell one output can be I can play outside or not, I can cycle outside or not. Okay, and also I can tell I can go to shopping market, I can go for shopping also or not. So for the same input x1, x2, x3, okay, activation function can be same, activation function can be different. Okay, you can choose it. I need some activation function for play, But I can choose different activation function, or I can use the same activation function for doing cycling outside. Okay, because the conditions for cycling and play is not same. For shopping, input may be same, but for shopping, activation function, the logic which will decide based on the inputs I will go for shopping or not, that can be different. Okay, so this is called as multi-output perceptor. What we call this as multi-output perceptor. So here each input will be connected to each output. See, this input is connected to all the three activation functions. This input also connected to all the three activation functions. This input also connected to all the activation functions. So such kind of network has a different name. What it is called as fully connected layer. This is also called as fully connected layer. Okay. So here every input is connected to every threshold logic unit or every neuron, every perceptron it is connected. Okay. Now we will see the how I just give some weights and give some inputs and do the calculation. But in real life, in real neural network, how these weights are getting calculated, how this prediction happening, what are the process? So there will be two things here. Okay. So let's take an example of again a simple neuron only, where you have x1, x2, x3. Weight are having w1, w2, and w3. So this is our activation function, and this is giving output y hat. So first w1, w2, w3. How you can assign weights to it? Because you don't know what in real life. I know it is whether it is play, it is other things, but in image there will be some pixel. Each input will be pixel of each pixel of the one of the each image, right? At that point, how will decide the weight? You cannot decide. So first you have to start with random weights. What you have to do, you have to start with some random weights value. Then you have to predict y hat. Then you have to predict y hat. Once you predict y hat, you can you have to calculate then error. Error means what is your y and what is your y hat. Depending upon that, you have to calculate error. Again, how to calculate error, we'll see in upcoming video. There are something called as loss function. Okay, based on this you have to calculate error. We'll see on details of loss function and all this. Now if error is high, then your output is not good. Then what you have to do, we have to update the weights. Update the weights. Weights means update the value of weights. We have to update weights. How to update weights? That is a so this process from assigning random values to getting the prediction, assigning random values to getting the predicted output, this is called as forward pass or forward propagation. Then after getting the output, you will calculate error using some loss function. Then we have to update weights. How to update weights? Using backward pass, or we can call this as also backward propagation. Here there will be some terms called as gradient descent. Okay, or optimizers. Mostly we call that as optimizers. What we call them as optimizers. Gradient descents or optimizers. So using those optimizers, you have to update the weight. You have to update the weight such that your error will be less in the next prediction, next iteration of predictions. So this is a simple example or simple outlay how a perceptron works. Now we will see some of the limitations. I will say this perceptron basically discovered in 1957. Okay, so This perceptron is discovered in 1957, but in 1969, in 1969, 1957, it was mostly discovered by Frank Rosenberg. Okay, but in 1969, Marvin Minsky and Seymour, I don't know how to spell their names, but Marvin Minsky and Seymour, they released a paper which highlights the limitation of the perceptron. So, which again took us back few decades, because the neural network has been, this is our first block of neural network has been discovered till then. So what is that limitation? Limitation is perceptron can only solve linearly separable problems. Means if you have if you have few inputs, let me, this is a class 0 and this is a class 1, then I can separate them with a single line. This is class 0 and this is class 1. But if I have some input where this is class 0 as well as this is class 0 and this is class 1, I cannot separate them using a single line. If I cross line like this, it is crossing this. I cannot separate them using a single straight line. For example, also I will tell a real life example. Let's take XOR gate, right? We have XOR gate, AND gate, NOR gate, NOT gate. Similarly, we have OR gate, XOR gate. So what is XOR gate? XOR gate have for 0 0 it will give 0, 0 1 it will give 1, 1 0 it will give 1, and 1 1 it will give 0. So for 0 0 it is 0, 0 1 it is, this is 0 1, 1 0 1. Okay, so this value is 0, this value is 0, this value is 1, this value is 1. How you will separate this in a single straight line? This is not linearly separable. You have to draw like this only to separate 0 from 1. This is one of the way. Otherwise, you can draw some curved line. For example, here, right? I can draw line like this to separate 0 from 1. It can be like this, right? It will be 1. This will be 0. So this is the limitation of perceptron, that it only can solve linear problems. It cannot solve non-linear problems. For that, we have a new concept called as MLP, multi-layer perceptron. What is this is called as multi-layer perceptron. That we'll see in our next video. So what we saw today, the perceptron is the foundational block of every neural networks. But of course, single perceptron cannot solve all complex kind of problems. Okay, but it gives the foundation. Whatever today we have big neural networks of having n number of layers, we are seeing having n number of inputs, having forward propagation, backward propagation happening. So those are all based on the simple concept perceptron. Okay, S- by combine, so uh, it's not only about understanding perceptron, it's also you should know how we evolve from perceptron to today's deep neural network. What was there in before and what was there in today, then only you can distinguish what's the evolution happened over the period of time. I hope this gives you a clear idea on perceptron, its working mechanism, and its limitation as well. Next video, we'll explore how multi-layer perceptron, which combines multi-layer networks and overcome the limitation of perceptrons, as we discussed. And if you want to cover any specific topics from data science, let me know in the comments. I'll try to cover those as well. And if you found this helpful, hit the like button, subscribe for more such videos, and hit the bell icon as well to stay updated for my upcoming videos. I will see the next one. Until then, keep coding, keep learning, and keep growing. Thank you.